Scene script. Have you ever wondered if humans could travel at the speed of light? Let's embark on a journey that transcends the boundaries of the ordinary into the realm of extraordinary possibilities. We are talking about a concept that has stirred the imaginations of scientists, space explorers, and dreamers alike: the mesmerizing concept of light-speed travel. The speed of light is something that has fascinated us for centuries. It's the ultimate speed limit set by the very laws of physics that govern our universe. The speed of light in a vacuum, to be precise, is the fastest pace at which any information or matter can travel. It's a speed that's incomprehensible to our everyday experiences, a staggering 299,792 kilometers per second. That's nearly 300,000 kilometers in a single second. Now, let's try to grasp the enormity of this speed. Think about the fastest thing you've ever seen or experienced. It might be a supersonic jet, a lightning strike, or even the blink of an eye. But even these are sluggish compared to the speed of light. When we talk about light speed, we're talking about a velocity so immense that it transcends our usual understanding of speed. It's a speed that doesn't just break records, it shatters them. It's a speed that allows light to travel from the sun to the earth, a distance of approximately 150 million kilometers in just over 8 minutes. It's the speed that governs how quickly we can receive information from our furthest satellites and probes scattered across the vast expanse of our solar system. And here's a thought to blow your mind. At the speed of light, one could travel around the Earth not once, not twice, but a whopping 7.5 times in just 1 second. Imagine at such a speed, one could travel around the Earth 7.5 times in just 1 second. But what would happen if we could travel at this mind-boggling speed? Well, imagine you're in a spaceship capable of light-speed travel. As you push the throttle, your ship surges forward, inching closer and closer to that elusive speed of light. According to Einstein's theory of relativity, some pretty strange things start to happen. First, your spaceship starts to behave oddly. As your speed increases, your ship's mass begins to rise while its length starts to contract. It's as if the universe itself is resisting your attempt to break the light speed limit. The closer you get to the speed of light, the more your ship's mass balloons and its length shrinks. Reach the speed of light, and your ship would theoretically have infinite mass and zero length. It's a mind-bending concept, isn't it? But the strangeness doesn't end there. As you hurtle through space at near light speed, time itself begins to warp around you. This is the phenomenon known as time dilation. Essentially, the faster you move, the slower time passes for you relative to the rest of the universe. It's like you've got your very own time bubble on your spaceship. Now let's put this into perspective. Say you're on a mission to a star that's 4 light years away. If you could somehow reach light speed, your journey would seem almost instantaneous to you, thanks to time dilation. You'd arrive at your destination feeling like you've just left Earth. But here's the kicker. Back on Earth, 4 years would have passed. While you've been zipping through space, life on Earth has been moving at its usual pace. So you could come back from your trip to find everything and everyone you knew drastically changed. So if you could travel at light speed, a trip to a star 4 light years away would seem almost instantaneous to you, but 4 years would have passed on Earth. But how close are we really to achieving light speed travel? Let's take a deep dive into the current reality of this intriguing concept. As it stands, our technology is leagues away from achieving the monumental speeds required for light speed travel. Just to give you some perspective, the fastest man-made object we've ever created is the Parker Solar Probe. This impressive piece of engineering hurtles through space at breakneck speeds of approximately 430,000 miles per hour. Impressive, isn't it? But here's the catch. Even at this remarkable speed, we're still nowhere near the speed of light, which zips along at a staggering 670 million miles per hour. That's over 1,000 times faster than our speedy Parker Solar Probe. So, you see, we have a long way to go. But speed isn't the only obstacle we face. the energy requirements for light-speed travel are truly astronomical. To propel a spaceship to the speed of light, we'd need an amount of energy so immense that it's currently beyond our capabilities to produce. And even if we could generate that much energy, how would we store it? How would we use it without causing catastrophic damage to our spacecraft? These are just a few of the many technological challenges that need to be overcome before light-speed travel can become a reality. There's also the matter of human endurance. Even if we could develop a spacecraft capable of light speed, could the human body withstand the immense forces involved in such high-speed travel? The effects of high-speed travel on the human body are still largely unknown, adding another layer of complexity to this already formidable challenge. While light-speed travel remains a fascinating concept, it's currently beyond our reach, but who knows what the future holds? After all, we've made incredible strides in space exploration and technology. With the rapid pace of scientific and technological advancement, the dream of light-speed travel might just be closer than we think. So, where does all this leave us? We've journeyed through the enigma of light speed, a concept that continues to captivate our curiosity. We've grappled with the mind-bending speed of light, a staggering 300,000 kilometers per second, and pondered the implications of reaching such a velocity. We've delved into Einstein's theory of relativity, which posits that as we approach the speed of light, time slows down, a phenomenon known as time dilation. This concept, while fascinating, also presents significant challenges for potential light-speed travel. And we've considered the current state of our technology, recognizing that we are still light years away from achieving this feat. Our fastest spacecrafts are but a tiny fraction of the speed of light, underscoring the monumental technological leap that would be required. Even though light-speed travel is currently a distant dream, the quest for it continues to inspire scientists and space enthusiasts, pushing the boundaries of our knowledge and technology.